My next speaker is Francesco Mondadori. I'm sorry, Francesco Mondadori from Opto Engineering. Francesco is going to talk about the benefits of area scan cameras with integrated liquid lens control. Francesco, looking forward to your presentation.
Good. So thank you very much for your introduction. I am Francesco Mondadori and I'm product manager at Opto Engineering. And as you mentioned today, we're going to discuss about benefits of area scan cameras with integrated liquid lens control. But first, let me say a couple of words about my company in case you're not familiar with us. Opto Engineering is an Italian company designing, manufacturing, and marketing imaging components, machine vision components. We started as a manufacturer of optics in 2002, so indeed this year we are celebrating our 20th birthday. But over the years we expanded our knowledge and know-how and product range, including also all the other main types of machine vision components. So lighting, including LED illuminators and pattern projectors as well. Cameras, machine vision cameras, and machine vision software too. All of this, of course, together with a complete range of dedicated accessories to, of course, say, to complement the products that I've just mentioned. But after this brief introduction, let me go back to the main argument of the presentation. And let me say a couple of words about, in general, about liquid lens technology. So, in case you're not familiar with it, what we are talking about, and some examples of employ of this technology in machine vision. So, here on the right side of the slide, you can see basically a simple scheme explaining what liquid lenses are. Basically, there is a fluid contained into a membrane that can be shaped thanks to a bobbin with a voice coil around it. And the membrane is made by piezoelectric materials that are materials that can change their shapes when an electric current passes through them. So basically, you can simply let some electric current pass through the membrane, thanks to this coil around it, and you can change the shape of the membrane itself. Basically, so you are changing the shape of the lens created by this membrane and the liquid inside it, so you can adjust the optical properties of the liquid lens itself, simply basically using a current, an electric current. Of course, this allows you to change the focus, so to refocus the lens, to change its properties. And this is extremely beneficial and brings a lot of advantages when compared to more traditional, if you want, or classic mechanical focusing mechanisms. The first and most important probably benefit is related to the speed, because here we are speaking about some milliseconds. So you can change the optical properties of the lens in a matter of some milliseconds, which is extremely fast. Something that would be impossible with a mechanical, let's say, focusing mechanism. Another important point is the design. Of course, this technology allows you to obtain a much more compact and robust design, not involving any stepper motor or whatever kind of mechanical solution you would be using. And it is also extremely reliable, because liquid lenses are generally granted for more than 1 billion cycles. So you can basically change and adjust the properties more than 1 million times before breaking them. And last but not least, of course, cost effectiveness. Because if you compare a solution including liquid lens with a traditional solution with mechanical movements of any kind in your system, you will end up realizing that this is extremely cheaper. It's much cheaper than the other one. But as I said before, now let's have a look at some practical examples of applications in machine vision. Opto Engineering started, as I said, as a company manufacturing optics, and so we started integrating liquid lenses in many of our lenses. The first case is the TCL series, featuring telecentric optics with liquid lens technology. Here you can see how they look like. So you can clearly see the liquid lens, and the integration of liquid lenses in telecentric optics allows you to change basically the focus, the plane of best focus of the lens. This allows you in turn to increase the depth of field of telecentric optics, which is extremely important, for example, when you're dealing with high magnifications, because the depth of field is inversely proportional to the square of the magnification. So the higher the magnification, the lower the depth of field, and it goes with the square root, so with the second power. So basically, it has a great effect on the depth of field. The magnification has a great effect on the depth of field. Thanks to liquid lenses, you can overcome this limitation, and you can use also high magnification lenses with a very high depth of field. We also took it a step further, and we decided to go with this very innovative design of a telecentric zoom lens with two liquid lenses. Having two liquid lenses allows you to change both the magnification and the working distance of the optics. And this is extremely, extremely useful because you can avoid, for example, Z stages, linear stages on the Z-axis that you would need if you were using traditional zoom lenses, for example. Another example, interesting example of application, this time is not related to telecentric optics, but it's related to some specialties optics of ours, which we call 360-degree view lenses. In this case, you're seeing a so-called pinhole lens, which is an optics allowing you to see the bottom and inner sides of a cavity thanks to a curved field of view. The liquid lens allows you to change the shape, basically, of this field of view, adjusting the lens to the specific hole or cavity that you're inspecting. For example, many times this type of optics is mounted on robotic arms, as shown here, to inspect complex objects with holes of different sizes, like this one, for example. And in this case, thanks to the liquid lens, you can adjust the field of view of the same lens to different heights and diameters. We have also integrated liquid lenses on another type of what we call the inner inspection lenses, represented by borescopic probes. Here you can see the working principle. So these are optics allowing you to see the inner sides of an object, placing the object inside, placing the optics inside the object itself. And thanks to the liquid lens, you can change the focus of the optics, and this allows you to inspect different diameters, keeping everything in focus. Again, this is extremely useful, for example, when you are mounting this type of optics on robotic arms to inspect different holes of different sizes. But now let's come to actually the nitty-gritty of the presentation. Aeroscan cameras with integrated liquid lens control. Well, the main product news that we have launched this year at the Vision Show, and you can pass by at our booth, is right over there. You can see it from the corridor. To see our own Aeroscan cameras, the S.p.a family. These cameras are entirely designed and manufactured in Italy by Opto Engineering. And they feature two series. First one is S.p.a G, featuring industrial GigaVision PoE cameras. So let's say classic cameras, if you want. And then we have the S.p.a GEL series, which is the main subject of the presentation, that derives directly from the S.p.a G one, but in this case, we have integrated liquid lens control feature in the cameras. And we will see in a couple of minutes the main advantages of this. In fact, this is the main point. Yeah, as I said, S.p.a GL series features cameras with liquid lens control, integrated liquid lens control. The cameras are all GigaVision and GenicAM compliant. And they feature resolutions ranging from 3.2 to 12 megapixels. Here you can have an overview of the product range. The cameras allow you to control Opto-tune liquid lenses, which are the ones that we integrate in all of our optics, without the need, basically, of an external dedicated controller or driver, if you want. This allows you to simplify a lot the vision system, and in the next slides we will see in practice what this means. Here are some key advantages of these cameras. Of course, the first one being that you don't need an external driver, as I said. The cameras have a rugged design, so a very robust design, with an aluminum body and a stainless steel lens mount, making them extremely robust. They are shock and vibration certified, and they have a wide operational temperature range. The cameras are made in Italy, and they grant high connectivity thanks to isolated POI supply, a broad range of IOs thanks to an iRose 12-pin connector, so a lot of inputs and outputs are available. And they also feature serial communication, so a combo RS 232 or 485 interface for maximum flexibility. The cameras also have a high processing capability to, thanks to a very large onboard image buffer for burst acquisitions and a high-performance FPGA. And we also grant a top-quality service with 5 years warranty, dedicated support directly from the manufacturer, and a fast replacement service with shipment from Italy in 48 hours, basically, working hours, a couple of days. Last but not least, the cameras also have a very interesting quality to price ratio, considering that they integrate the control of liquid lenses and you don't need to purchase the driver separately. We also designed a dedicated cable, customized cable, allowing you to connect directly the liquid lens to the camera and then with the same cable to go directly to the PC. We will see a scheme in a couple of minutes, and I will show you what I mean with this one. We also provide a complete SDK, so a software development kit, which is GenicAM and GNTL compliant, and a fully featured GUI viewer for camera control, streaming, and monitoring. Inside this GUI, there is also a branch of the GenicAM tree, allowing you to control the liquid lens directly from the camera, as shown here. This is actually it. this is the real benefit of this type of cameras. So in this picture, you can see the comparison between, let's say, traditional system when you're using optics, where you're using optics with liquid lenses. So you basically need one cable to go from the camera to the PC, of course, if you are using it with a PoE supply, power supply. If you're not, when there is also a second cable from the camera to the PC, it's even more complex than this. Then there is the liquid lens that needs to be connected to the driver with another cable, and then a third cable from the driver to the PC. Of course, this is a quite, if you want, complex system. On the other end, if you use Itala GEL cameras, so with integrated liquid lens control, you can simplify the hardware because you have only this cable, the customized one that I mentioned before, allowing you to connect on one end the liquid lens to the camera, and on the other end, the camera to the PC. So just one cable, no drivers, no other hardware here. So you can simplify the system. It is easy to control the liquid lens using the camera SDK, as I showed you before. And you can reduce the cost because you have less components and less installation expenses, because anything is easier and more, if you want, ready to use, because anything is meant to work together in perfect synergy, basically. That's pretty much it from my side. Thank you very much for your attention. Here you can see my contacts. If you want to reach out for me, I will be more than happy to answer all your questions now, or if you want to write me, here you can see my contact. And I would like to invite you to see our booth if you have the chance, which is 8D48, right over there. Thank you very much again for your attention.
Thank you, Francesco from Opto Engineering. Are there any questions? Please raise your hand. We have a microphone here. No questions from the audience today. Let's look at the chat. No questions from the online audience in the live stream. But I might have a question.
Sure.
Where do you see the most promising demand and applications for your cameras with liquid lens control?
Well, of course, whenever you are using a liquid lens, this type of product is, beneficial because, of course, as I said, you can simplify the integration, it's ready to use, and so on. Liquid lenses are widely employed, for example, in logistics applications, where you have maybe packagings of different sizes, so you need to refocus at different distances, but also in many other fields, such as 3D reconstructions as well. Mm-hmm. So you have the so-called Z stacking, where you take multiple images at different distances thanks to the refocusing of the liquid lens, and then you reconstruct the whole image in focus with these images you acquired before. In all those cases, anyway, when you're using a liquid lens, a product such as these cameras is extremely useful and recommended to make the best, basically, to get the best out of your system.
Okay. Thank you, Francesco.
Thank you very much. Again.